Two types of pressure systems getting into the weather. These are going to be critical for you to understand going forward through the course, and how the winds circulate around high and low pressure. Those particular pieces of information will be critical in terms of how the weather is going to affect you as these systems move across the country. Where are air masses interacting with each other? Would be their cold fronts and warm fronts and stationary fronts. And then how the wind flows around the high and low pressure. So this is basically what drives the weather, the progression of high and low pressure systems across the country. High pressure systems are called anticyclones. That's the word we use for a high pressure system. And you can see in the schematic, the wind rotates around a high pressure system clockwise. And low pressure systems are called cyclones, and they rotate counterclockwise. The air rotates counterclockwise around them. Observations across the country have all sorts of symbols, and you can see precipitation symbols on the right side of this menu here. Rain is a dot, drizzle's got a little hook on, comma hook on it, and all these different symbols. And we use those to kind of track where the weather, what weather is occurring at any point in time across the country. So we'll move forward here. Highs produce fair weather. The air is sinking. As the air is rotating clockwise, the air is sinking over a high pressure system. So, generally clouds are not forming if the air is sinking. And these systems track generally from the west to the east or southeast. Low pressure systems are rising air. The air is rotating counterclockwise in the northern hemisphere. So as that air rotates counterclockwise toward the center of a low pressure system, there's convergence and the air rises when it converges together. Rising air creates clouds and precipitation usually. So these systems track usually east-northeast across the country based on the jet stream flows. The weather to the north and the west of a track of a low pressure system is usually colder, to the west and north of that low, and to the south and east where the warm air is coming from is usually a little bit warmer, a little more precipitation. So those are the general characteristics of high and low pressure. Here's a schematic of the airflows around high and low pressure. You're going to be analyzing in your assignments this week. You're going to draw these actual lines of constant pressure on a weather map. We'll give you a snapshot of the weather at any particular hour, and you're going to get a couple of example lines across the country, and then you're going to fill in the rest on 4 millibar intervals, and then you're going to create complete lines of constant pressure across the country, and then you'll do the same around any area of low pressure on the country on the map. But this particular schematic here just shows you the air, how it will flow across those pressure lines toward the center of low, and across the pressure lines away from the center of the high as the air is sinking. So the air sinks and it has to go somewhere, so it moves away from the high. Here the air is rising, so you need a feed of air to supply additional air, because once that air starts rising, you'll create a vacuum at the surface, so to speak, and you'll need air to fill in again. So as that air starts converging toward that low, it'll be spinning in a counterclockwise direction. So those are critical elements you're going to be asked to answer in questions throughout your assignments during this course. Air masses. Basically, the Earth is covered with air, and it gets influence from where the air is sitting. If it's sitting over a cold land, it's going to get cold and dry. If it's sitting over the tropics and the ocean, it's going to get warm and moist. So as air sits in any particular location for any amount of time, it gets the characteristics of that particular region or source region. And we characterize air masses by, if it's over a continent and it's near the poles, we'll call it a continental polar air mass. Or if it's over the tropics, over the ocean, we'll call it a tropical air mass. So basically, just understanding that air masses are moving around and they maintain their characteristics from their source region, but they'll evolve as they move, as the air moves from the ocean over land. It'll start to dry out, and basically that means produce precipitation, so the moisture falls out of the atmosphere into the ground as rain. We'll be analyzing that, and the basic premise here is as air masses move and clash, you have frontal boundaries that form between those. And air mass characteristics are basically driven by temperature and humidity. And we'll analyze that a little bit more as we go through the course. The polar air masses are cold in winter and milder in summer. Tropical air masses have less variation, basically because there's uniform sunlight across the tropics throughout the day, no matter what season it is. The sun is very close to the equator, and the days are usually 12 hours of light and 12 hours of night, almost all year round, just because the sun is closest to that point on the Earth as it rotates. And then the air masses move and take the characteristics of the area they pass over, so they're going to modify as they move across the globe.